We are Team 2, and today we'll be presenting Saxby's Coffee supply chain improvements. An agenda for this presentation will begin with a background, followed by the current conditions, our goal and target conditions, cause analysis, proposed improvements, and conclude with a follow-up.
I will now be discussing the current conditions and the relevant facts and figures. The Saxby Coffee location is split into three stations: the host station, the BevX station, and the barista station. The customer process cycle starts with the host, who takes the order, the payment, and then writes the name on the cup, which provided to us was 34 seconds, but I included a total station time of 38 seconds for the occasional person who plays with cash instead. From there, it goes to the BevX employee, who does have an additional idle time of 38 seconds, to be noted, who will then pump the syrup and grind the coffee, taking an additional 13 seconds. From there, they pass it off to the barista, who will tamper with the espresso and then add whatever shots of espresso, brew, or pull is necessary, heat milk if necessary. These things can be done simultaneously for an additional 22 seconds. They will combine the espresso and the milk, and then lid and serve for a total of 91 seconds. It is to be noted that the total idle time from this process from start to finish is 38 seconds plus 58 seconds, which is significant, which goes into our next point. Some of the non-ideals about this setup so far is that there are significant delays caused by the restocking during peak hours. It is noted in the report that occasionally the significant inventory restocking needs to occur just because they run out of materials during peak hours, and this could take anywhere from 10 to 15 minutes. So we're going to assume kind of an average dead wait time of about 12 and a half minutes. The bottlenecks occur with the host and barista, who have significantly greater periods of time than the BevX employee. And then the BevX and barista do have significant idle times as well, just because the coffee itself has to go from station A to B to C, kind of incurring significant idle time that we use for better things. Some of the relevant facts and figures include a max cups of 75 per hour, meaning that only 60% of demand is able to be met during peak times, and that during low times, 234% of demand is met if people stay at their stations, meaning that this is actually an over allocation of resources. And instead of being stationed at their station, employees could restock, could do administrative work, could do whatever behind the scenes that is needed, better much spent during the low hours. And so, accounting for the inventory restock, we're going to assume an average dead weight of 12 and a half minutes, because that is the average that was provided to us.
Now I'll be talking about the cause analysis, starting with the underlying issues. The fundamental problem facing Saxby's is that its capacity is too low during peak hours, which directly causes long wait times and lost sales. Starting off with the capacity gap. The system's maximum output is only 75 cups per hour, as you can see in the calculation below, while the peak demand is 124 guests per hour. The wait time, as the process cannot meet demand, it leads to line buildup and wait times that exceed the target of 5 minutes or less, causing students to leave without ordering. Last but not least, we have system utilization, where the system is being pushed far beyond its sustainable limit during peak periods, as calculated to 165% utilized, which is an unsustainable state where lines will grow indefinitely. To further analyze that cause, we created an Ishikawa diagram. Starting off with the process root cause, which is the most critical. The barista station is the bottleneck, as it contains the longest and least flexible tasks. The multiple steps, including grinding, tamping, pulling, steaming, and combining, accumulate to a very high cycle time per cup. There is also frequent restocking interruptions. Workers regularly leave stations to retrieve milk, syrups, lids, cups, etc., and these interruptions increase cycle time and idle downstream stations. There is also a sequential workflow with minimal parallelization. Many steps cannot begin until previous steps are completed, especially combining milk and espresso. There is also an uneven task distribution, as the host is underutilized at certain times while the barista is overloaded. This leads to the root cause number 1, where the barista station is the dominant bottleneck whose long processing times and interruptions determine overall cafe capacity. Next, we have the people or the workforce root causes. First, we have no designated floater or support position. No one is responsible for restocking, running supplies, or supporting station overload. The student workers may also be inexperienced, leading to variable task times like inconsistent tamping, or milk steaming. The cross-training gaps may also prevent flexible shifting during peak demand, leading to root cause number 2, the lack of a flexible support role, leading to workflow disruptions and preventing balancing of station workloads. Third, we have the environment and demand root causes. The 10-minute class breaks create extremely concentrated demand spikes, compressing high volume orders into short windows. Students are also time constrained, meaning even minor delays translate into walkaways. The single line file system also does not allow for dynamic load balancing of app or mobile orders. These are external constraints, but exacerbate the internal bottleneck. Last but not least, we have the equipment root causes. The espresso machine cycle time of 22 seconds per double shot is fixed. There is also a limited preparation space that may cause congestion and slower handoffs. The milk steaming can also not be fully automated, and only one steaming one is available during observation. While equipment is not the primary issue, it intensifies the bottleneck by limiting barista capacity. The core root cause is the barista station bottleneck, amplified by workflow interruptions, such as restocking trips and uneven labor allocation. The barista station determines system capacity because it holds the longest, least flexible tasks. However, capacity is further reduced by workers leaving stations for restocking, causing cascading delays throughout the system. Hence, our solution, introducing the floating team member, directly addresses this root cause, as they will help to absorb restocking tasks to reduce interruptions, support BevX and barista during peak workflows, which help to increase parallelization. They will also help to reduce idle time and balance station workloads, which in turn can help improve flow efficiency. They will also increase effective capacity at the bottleneck in the barista station, reducing overall line wait time. Overall, this can help to also achieve our second goal of helping to achieve the target 10% reduction in total drink preparation time. Now I'll be talking about proposed improvements.
Hello, today I'm going to discuss the changes that you can make to reach your set goals. First, you can consider hiring a new employee that is a floater and will handle all restocking duties, pre-stage supplies and products, support other associates, along with help pick up slack in the bottleneck regions like grinding and tamping. Second option is a workflow redesign. Align milk steaming with espresso pulling, shift non-value added tasks away from the baristas, improving handoffs, and achieving a more balanced work across all station. Last, we would recommend a reduction in restocking. Supplies can be restocked before and after shifts. Nobody leaves their stations unless needed. Overall, we would suggest hiring the floater employee, as the other options do not meet all of your goals and are, however, they are less expensive, good options. The floater would reduce latte production by over 10 seconds and increasing the amount of cups an hour by 6. This aligns with your 10% reduction wait time goal. The floater would be paid $15 an hour, and because of this increase of productivity, the drink average revenue will be $5.65. This improves the wait time for customers, allows for more consistent drink quality, and better employee flow and ELP learning outcomes. Now here we have the original workflow diagram showing each individual task required and how long it took for it to be completed. And as you can see, this is the updated workflow diagram with the implementation of the floater employee. This is reducing times across the board, especially during the pumping syrup, grinding coffee, timbering espresso, along with heating the milk in a shot of espresso brewed or pulled. And this is the updated flowchart for latte production, including all of the updated times due to the addition of the floater employee. As you can see, taking the order only takes 10 seconds, processing payment only takes 12 seconds, labeling cup takes 6, pumping syrup takes 6, grinding, tampering coffee only takes 11 seconds, adding the shot of espresso takes 19 seconds. Heat and steaming the milk takes 19 seconds. And here we have a split off where the customer may not want the milk. And if they don't, then they can go ahead and lid and serve, which is 6 seconds. Or we can go ahead and combine the milk and espresso, which takes 20 seconds. And again, lid and serve, which takes 6 seconds. Thank you.
All right.
Lastly, I just wanted to go over the follow-up plan and some of the metrics we can use to track the success of this plan. So, firstly, I just want to reiterate what the pilot program is. Over a 2-week period, we will introduce a floating team member who will be scheduled during peak hours to assist with operations in any way they can to decrease wait times. This could look like restocking, helping baristas, or even helping with the BevX machines. Now, how are we going to measure the success of this program? Well, we're going to do that through two key KPIs. One, we hope to see an average wait time decrease of at least 10%. And also, we hope to see a meaningful decrease in walkaways within the line, which are people who are in the line and walk away because it's either taking too long or the line is too long. Um, Now, with that being said, there are a few potential issues we could run into, such as decreased quality of drinks or order errors. These types of problems can be tracked through drink remakes, because if you're remaking the drink, there's obviously something wrong with it. The other problem we could run into is staff stress and complaints. And the best way to manage this is just by checking in with the staff after each shift, seeing how the pilot program is working for them. Now, assuming the success of this program, we would like to standardize the floater role with clear responsibilities during peak times and adjust our layout and process in order to accommodate the changes. To conclude this, our overall recommendation is to use this floating team member as a focused, data-driven way to relieve peak time bottlenecks without overstaffing across the whole day. The pilot, the metrics, and the follow-up plan give Saxby's a low-risk way to test the idea, learn from it, and either scale or refine it. Thank you for your time, and we are happy to answer any questions you may have.